the density lab. So the purpose of our lab is to use your measuring skills, manipulate equations, and solve for unknowns using significant figures. So flip it back over to the procedure side. There are 3 parts to our lab today. How many parts? 3. The first part, you're going to determine the identity of an unknown metal given to you by calculating its density and comparing it to the densities on our periodic table. So periodic table in the front, periodic table in the back. The bottom right-hand corner gives you the density of the metal. It's right here, density of the metal. So barium has a density of 3.51. Note to self, all of the metals in column 1 are called the alkali metals, and the alkali metals are explosive to air. So do you think that any of the metals I'm giving you are alkali metals? No. Right, no. So I love you that much, which is why I did not give them to you. No, so if you're finding like you're like, hey, we've got sodium. No, you don't. So the first one you're going to do, you're going to figure out what metal you have. And if we look at your answer sheet area, the first thing you're going to calculate is the mass of your metal. And what measuring device will you use to do that? The electronic balances. Fantastic. So you're going to record all of the data from your electronic balance, and then you're going to calculate length, width, and height. And some of you have a cylinder, and so your equation may require you to calculate radius, to calculate volume. So over here on the side, I should see V equals L, W, H equals something, something, something. So when I say show me your work, this is what I want to see. If you don't show that to me, you don't get credit for doing the work. No naked numbers. Every number in science is a measurement. Every number has a label. Now, if you don't have a square or a cube, if you don't have a cube or a rectangle, then this equation doesn't work for you. You need an equation for a cylinder. So you will need the equation for a cylinder, which is pi r squared h. So if you go back in lab and your solid object is a cylinder, then you will be measuring pi r squared h and showing your calculation for volume there. So then give me your volume answer with the correct derived units. So if I have centimeters times centimeters times centimeters, Carmen, what's my derived unit for volume? Yep. If I have centimeters times centimeters, fantastic. I have centimeters cubed. So density, I'll put density equals mass over volume equals something divided by something equals an answer. And then you'll show me the density. You'll use the periodic table. And I would encourage you to just do that last. Do all the calculations and then figure out what you have last. Okay, then you'll tell me, we think that our metal is something. The second part of the lab, I'm giving you a copper plate. So what element do you have? We're just going to look up the density of copper. So you'll look on the periodic table, what is the density of copper? And my question for you is, what is its thickness? So this is the copper plate. There's one at every lab station. And so you're going to need to use your math skills to work with the equation to solve for how wide it is, its thickness, okay? So let's look at our equation down here. It asks me what's the length. Well, I can measure the length. So I use my ruler. I hold it up. Now, if you note, where's my camera? Do you see how on the end of my ruler here it's damaged? So if I make measurements directly from 0, are they going to be as accurate as possible? No. So I should start at 1 because I can clearly see where 1 is, and then subtract 1 centimeter off. So when I make a measurement, here I see that this is recording to 6. Well, I'm going to subtract 1 from it because it started at 1, so it's at 5. 5.65. It's not 7, but it's more than 6. So my answer would be, and don't record this on your paper because this is not necessarily your medal, but my length would be 5.65 centimeters. So that's the measurement, that's the precision of my ruler. All of my answers should have 3 sig figs. If you measure it and you're like, oh no, that's exactly on, then let's say like it was exactly 2. So my answer is 2.00 because that's the level of precision that this ruler communicates. Make sure that you keep that in mind when you're making your measurements. So let's look at the equation to solve for your H. So density for copper. Density is on my periodic table. Look it up. Mass, how am I going to find this? Well, weigh it. Put it on the balance. So measure. Length. Use your ruler. In this case, width, we're going to use your ruler. And I want to know its thickness. So we're going to call that H. Can I accurately measure this thickness using my ruler? No. So I'm going to solve for it. So your equation is D equals M over L W H. I observe that H is located where? Ashley, where is it at in my equation? It's in the denominator, so I need to get it to the top. So how do I get it to the top? So it's currently dividing, so the up is multiply. What I do to one side, I do to the other. So now I have HD equals MLW. How do I get H by itself? Divide on both sides by D. So I get H equals M over LWD. M, I measure, L, I measure, W, I measure, D, I look up for copper. Okay. Use your sig fig rules. Use your significant figure rules in calculations. Do not give me calculator junk. And then you're going to calculate percent error. So if the copper actual thickness was 0.0122 centimeters, what was your percent error? So the equation for percent error equals the absolute value of the actual experimental value minus my theoretical, what should it have been, divided by theoretical times 100. Turn it into a percent. So actual, what did you actually get in lab, minus theoretical, what was it theoretically supposed to have been, I gave you that in the problem, divided by theoretical times 100. And it's the absolute value because I don't care if you had too much or too less, I just want to know how far off were you. Okay? So, part 1, do your object. Part 2, thickness of copper. Part 3, the density of the liquid. So there is a bottle of alcohol at each of the lab stations. So the density is not 1 because it's not liquid water. It is an alcohol solution. And I'm asking you to take out between 20 and 30 milliliters of solution. Does it matter that it's exactly 20? No, as long as you know exactly what you have, okay? So this is one of the few times I'm going to tell you to put the solution back into the bottle when you're done. So there's 1 per team, so so take your measurement, put your graduated cylinder onto the electronic balance, always use the same balance, measure out your 20 to 30, record what it is, 24.50, record mass, and then calculate the density of the liquid. And then it gives you, if the density of the alcohol was actually 0.725 grams, what was your percent error? Okay, so 3 parts. How many parts? Let's go ahead, and I don't see any reason why you can't get, you could potentially get data for all 3, but let's see that you get at least data for 2. Okay? Questions for me? Nope. All right, then let's work in teams of 2.